Last subject in section 4.1 is equations of inverses. So equations of inverses. And again, so we can find the inverse of any equation. So technically, again, these are looking at one-to-one functions, right? So if the function is not one-to-one, then its inverse would not be a function. So for instance, like this one. So that's not one-to-one because it's a quadratic. So that means, because it looks like this, and so the inverse would be a square root, which is not a function, right? So you could find the inverse equation, but I guess technically it is not an inverse, is what the book says. But you can still find the inverse equation, but I guess technically you're not supposed to call it an inverse. But that's fine because the steps allow you to find the reverse of everything. So I'm still going to call it an inverse. But if it's not one-to-one, these directions say that if it's not one-to-one, then you don't need to find the inverse equation or the inverse function, right? So the big thing is if it's not one-to-one, the inverse will not be a function, right? Because it doesn't pass this vertical line test. But I would just practice it anyways, so you get used to just finding the inverse. Whether your function is one-to-one or not, just do them anyways. So then you can find the inverse of any equation. So the steps are, I did them in class, but here's just 1, 2, 3. So step 1 to finding the inverse of an equation, or of an equation, is just they use the words interchange. So step 1 is interchange. Interchange your x and y, because basically finding the inverse is switching your x's and y's, so that's what you're going to do. So you interchange x and y. Step 2 is you solve for y, and step 3 is replace y with f inverse of x. F inverse of x. So there could be a pre-step here because none of these have y's in it, right? So you might be confused. Interchange x and y when there is no y. So you might have to change or switch f of x, or y for f of x. So you might have to do that before, or you don't even have to, right? Okay, so those are the steps. I'm about to erase them, so if you need to pause it, or just rewind it, I guess will work too. Okay, so we can change this to y equals 2x plus 5. Ooh, plus 5. And then we can go ahead and interchange x and y. So x to y plus 5. Then we can solve for y, get y by itself. So x minus 5 equals 2y. And then divide by 2 on both sides. So you could leave it like that, or you can go ahead and write 1/2 x minus 5 halves equals y. And now we can go ahead and erase that y and change that to f inverse of x. So there's that one. Okay, so like I said, this is a quadratic. So since it's not one-to-one, this one is one-to-one because it's linear, right? This one's a cubic, so it is one-to-one. Because cubics look like this, right? So it actually does pass, even though this one doesn't look like it passes. It does pass. Not all cubics would be, I believe, like something like this: x cubed minus 2x squared plus 1. That would not pass because that would look something like that, and then it wouldn't pass. But these, where you're just cubing the entire thing in parentheses here, that's going to look more like a normal cubic, because all this does on the inside is move it to the right or left, right? It just moves our standard cubic to the right too. So it's going to pass the horizontal line test. Okay. Same with to the 5th and to the 7th and all odds. Okay. So this second one, it's not 1-to-1 because it's a quadratic, right? So technically by the directions here, I don't need to do it, and I can just say not 1-to-1. But I'm going to go ahead and do it anyways. So technically, I guess I'm not really finding the inverse, but I'll still call it the inverse anyways. So we switch f of x to y. And probably why they don't call it the inverse is probably because we say inverse function, and since it's not 1-to-1, that means the inverse would not be a function, so that's probably why they don't call it inverse. But maybe there are some books that do call it like that. I'm not sure. Change x and y, and then go ahead and solve for y. So x minus 5 equals y squared. Get rid of the squared by square rooting, and here's where we can see why it's not going to be a function. Right, because when I square root both sides, I square root my y squared and I get y, but when I square root this x minus 5, whenever I square root I have a plus or minus, right? So that means I have, for my 1x, when I plug an x in here, I will always have two answers, right? So on my mapping thing, whatever my x is, it will always go to two different y values. So there's two arrows coming out of here, so it's not a function. And then you can go ahead and exchange y to f inverse. So that's fine. But again, if you just want to say not 1-to-1, I'm okay with that, because then I know that you know how to identify a quadratic, and a quadratic's not 1-to-1. So I won't mark you down if you do it, and I won't mark you down if you just say not 1-to-1. Okay, cubic, it is 1-to-1. So we exchange y equals x minus 2 quantity cubed. And then we go ahead and exchange our x and y, or interchange. Get rid of the cube first, right, because it's on the outside. So we cube root. So we have the cube root of x equals y minus 2. We go ahead and add 2 to both sides. We're not going to add that 2 on the inside of the root, it's on the outside, so it's the cube root of x, and then add 2 equals y. Switch that to f inverse of x, cube root of x plus 2. So there's our inverse function. So these are technically inverse functions, and this is not an inverse function because that is a square root, so it's not a function. Okay. So real quick note, even probably doesn't mean, or the square root one. So sometimes, we say this is a square root function, but I just said it's not a function, right? Because it fails the vertical line test. Well, that's why if we do restrictions on this, right, and we say, okay, well, what if I cut it off right here, and I say no x's, I could label that. What we do, we can't really put a restriction on it, but what we might have talked about this a couple years ago, but we talked about where we kind of just look at only the positives, and I can't recall what that term was. It was either proper or prime. I'm thinking it was proper, maybe, where we only look at the positive root, and we don't look at the negative root. So that's why sometimes, usually when you see square root functions graphed, they're only graphed like that. And I believe that's the proper root, and because we only want to look at the positives, so then it's actually called a function, right? This would be called a function because it passes when we only look at the positive one, or if we only look at the negative one. That's probably a sidetrack, but that's a. So here's a function, right? So this one does have a restriction, and why it has a restriction on it is because when we put in 4, we get 0 in the denominator, which we can't have. Now this is a function, right? And we could actually graph this. You learned how to graph it in chapter 3, right? the same degree, 1, 1. So that means our horizontal asymptote will be the coefficients, which is 2, so y equals 2, so 1, 2, horizontal. And then we have the right here, our restriction, that would be our vertical asymptote, because we can't cancel any like terms out or like factors out. So at 4, 1, 2, 3, 4. And then what's going to happen here, we can plot in some points. We can plug in 5. See what we get. We get 13 over 1, so 13, so somewhere up here at 5. So that means our graph's going to go down like this. And so you notice that passes the vertical line test, because it only crosses once. And then over here, when we plug, say, 0 in, we get 3 on top and a negative 4, so negative 3/4. So somewhere right here, so it looks something like this. And then we could also test, to see if it crosses that horizontal line, but it's not going to, because when I plug in 2 for my f of x, I could solve that, and what's going to happen is I'll get like 3 equals something. 3 equals -8, so then it doesn't work. So there's our graph. So it passes the vertical, and it also passes the horizontal. So it's actually, this is a 1-to-1 function. So we can find it does technically has a inverse function. So these are a little bit more tricky to actually solve, but we know it is actually 1-to-1. So how you solve this one, switch y and f of x. Switch your y's and x's, so then my x's are now going to be y's, and my x, and like I said, you can wait till the end to do that too, to switch them. Oops. And now we solve for y, so we're trying to get y on by itself. We've kind of solved these a little bit a few months ago, maybe quite a few months ago. But we need to get all my y's on one side. Well, the only way to get this y from the denominator is to multiply by y minus 4. So I do that to both sides. I distribute that x, so xy minus 4x equals 2y plus 3, because these cancel out. So I get rid of that fraction. Now I'm trying to get my y's on one side, right? So this y and this y need to be on the same side. So if I want minus 2y, I'll have xy minus 2y. And then minus 4x equals 3, and then I can add 4x to both sides. So I get xy minus 2y equals 3 plus 4x. Or I could have did it the other way. I could have moved. I could have subtracted xy on both sides. I can't subtract x, just plain x here, because these are tied together by multiplication. And I don't want to divide by y to get y by itself, because then y would be a denominator over here. So you have to subtract that over, that xy over, or subtract this 2y over. Now that the y's are by themselves, what's the same in both of these terms? A y, so factor out a y. And now we only have one y instead of 2 y's. And then to get rid of multiplication here, we divide by x minus 2 on both sides. So here y is equal to 3 plus 4x over x minus 2. Switch that to f inverse of x. And then we could also label our restrictions, right? Because we can't have 0 in the bottom. So our restriction would be x cannot equal positive 2. So that's how you do that type. So number 77 and number 81, basically they give you a graph like this, and they give you some sort of graph, and they ask you to find the x-intercept, or find the inverse function. So how you do these ones is you find some point, so say 3, say this is 4, so you got 3, 4. So the inverse would be then, it would have some point 4, 3 on it, right? Because I just switched the x's and y's. And then I'd find a second point, say 0, -1, say this is -1. And so I'd switch that one to -1, 0. And then I'd plot these 2 points. And then I can graph my inverse function at 4, 4, 3, so somewhere right there. And negative 1, negative 1, 0. And then I can go ahead and graph that inverse function. So that's how it would look. So that's like number 77 and 81 on your homework. So here we want to find the inverse of f of x equals square root of x plus 5. So again, this is square root, so it's actually not a function, so it's not one-to-one. But what the book does here is they restrict the domain. Because remember, if I put in negative 6, negative 7, it would be the square root of a negative number. So really, I couldn't even graph it on that. So what they do is they restrict the domain for x is greater than or equal to negative 5. So everything greater than or equal to negative 5. So negative 5, negative 4, negative 3, 2, 1, and all the way up. So that's one way to do it, but they kind of don't mention that they're only really looking at the positives here. So they're not even looking at the negative square roots. They're just looking at plus square roots, the positive square root. Okay, so they restricted it so that you can't have any square roots of negative numbers. I looked back in the section, in the review section, section 7 of the review, and the word is for just a positive root is called the principal root. So that's kind of what they're doing here. So this is why they call it a one-to-one function, because they're only looking at the positive side, and they're also getting rid of those possible square roots of negative numbers. By the restriction here, they get rid of the square roots of negative numbers, and by looking at just the principal square root, so just this one, that's why they consider it one-to-one, because it passes the vertical, because it continues to increase here, and it passes the horizontal. So that's why they can say this is a one-to-one function, because of this restriction, and they're only looking at the principal square root. Okay, so let's go ahead and find the inverse of this. Okay, so change f of x to y. Interchange x and y. Solve for y, get rid of the square root by squaring both sides. So you get x squared equals y plus 5, subtract 5 on both sides. So you can see that, hey, as we look at this, we change y to f inverse of x. So as we look at this, we see we have the inverse is a quadratic, which is not it's not a one-to-one function, which is okay. It's okay if the inverse is not one-to-one, but because of that restriction, that means that our domain for this one is going to be different. So I can't have the domain of this inverse function because of this restriction. So the restriction of the original function was this, right? So when that happens, that would be my domain, correct? So if that's my domain, that means that my y values for this one, because remember, my x's become my y values of my inverse. So my range of this one is y is greater than or equal to negative 5. And so what that means is, what's my domain for this inverse? Well, the domain of this inverse will be the range of the original function. And what is the range of the original function? Well, as we put in negative 5, so we plug in negative 5, we get 0, right? Negative 4, we get 1, so it's something like this, and it goes on forever. So that means from 0 up, that would be our range, from 0 up, and it does hit 0, so 0 up to positive infinity. So that would be our domain. Our restriction on this inverse function would be the range of our original, which is from 0 up to positive infinity. Or you can say, if you want to do interval notation like they did, would be x greater than or equal to 0. That would be our restriction on this inverse function. So definitely find the inverse, and then we can maybe discuss this in class a little more of actually how to find the restriction on that. So whenever your original has a restriction, that means your inverse needs to have a restriction as well. So that, I believe, is number 75 on your homework. And I'll go ahead and start working on those homework problems now. There's also a thing on page 392, some important things about inverses that you could look through. So here are the homework problems. There's a few more. Well, we've done these ones, so I believe we're up to here. So these ones right here, and added a couple more. So we'll go ahead and start on 59A, and you can pause the video anytime. I'll start working through these. So again, this says if it is 1-to-1, right? So if it's not 1-to-1, and remember you're just doing A. So if it's not 1-to-1, you can go ahead and just say it's not 1-to-1 and not do it, or you can practice and find the inverse. But if it has restrictions on it, then you probably can't. Then you probably should do it, because they're trying to probably tell you that, hey, I'm giving you restrictions so that it is 1-to-1, and you can go ahead and find the inverse function. So you can exchange your x and y here. You can add 4 to both sides. As soon as you start doing these, you realize, hey, aren't I just doing the opposite of everything? Aren't I just really just solving this for x, basically, and then just switching x and y, and then changing my y to f inverse? Yep, that's basically what you're doing. And then we divide by 3. We can leave it like that. So f inverse of x plus 4 all over 3, or I can separate it and divide each of those by 3. So any one of those is the same thing. Okay, so here's 63A. This is 1-to-1 because you have a cube, so it looks like this. Normal cubed, right, just x cubed is 1-to-1. It passes the vertical and the horizontal. This +1 just moves this graph up 1. And then it looks the same. So it is also 1-to-1. So here, you exchange y for f of x and then switch your x and y, or you can just really just do the opposite and solve for x. So f of x minus 1 equals x cubed. Cube root both sides. So the cube root of f of x minus 1 equals x. Now switch f of x to x, just plain x. X minus 1, and switch that x to f inverse of x. Done. Okay, so here's 65A. As we can see, this is a quadratic, so this is not 1-to-1, so you could stop there if you want to. If they would have restricted the domain and said, okay, x has to be greater than or equal to 0, then it would be 1-to-1, because then it would only be looking at this side of the graph. Or if they said x is less than 0, then they would be looking at this, and then that would be 1-to-1. So you can just go ahead and practice this. What it does is just, if it has a restriction, that means the inverse will also have a restriction. So you can just solve this for x minus 8 on both sides. You get x squared, square root both sides. Switch y to x. Switch x to y, and then change it to f inverse. So there's the answer to that. So sometimes after you practice these quite a bit, you get pretty good and pretty fast at them, where you can pretty much do it in your head, because you're just doing the reverse operation of adding, reverse operation of squaring, right? You just kind of work from the outside in. Okay, so here is a rational function, and it is a function. It's actually 1-to-1. Look, something like this. And at 3, 2, 3, so that's 3. So then it looks something like this, either down like this and up like this, or over here and over here. So it is 1-to-1 because it just has 2 branches. So it is 1-to-1. So we can switch this to y. This is where it'd be hard to do the opposite or reverse operations here, because we have an x on top and an x on bottom. So we have to get rid of this x on top, or on bottom, sorry, by multiplying by the denominator on both sides. So you could do that now before you even switch the x's and y's, or you can switch the x's and y's first, it doesn't matter. So that means I need to distribute this y to the x minus 3 here. So yx minus 3y equals x plus 1, because these cancel. Then I go ahead and move my x's to one side. because I didn't exchange this y and these x's yet. So that's why I'm solving for x. In the previous example that I did, I exchanged the x and y's already and I solved for y, but here I haven't done that, so that's why I'm getting x by itself. So I need to put those two x's on one side together, so I'll subtract this x and I'll move over this y by adding 3y to both sides, factor out an x, and that's minus 1, right, because negative x divided by x would be negative 1. So don't just leave it as y. Now I can divide by y minus 1. Now I can write it in inverse form. And because I had a restriction on my first function, I should have a restriction here. And because it's a rational function, I need to exchange my y's and x's, right? So these need to be x's, not y's. And then what makes the denominator 0? That'd be 1, so x cannot equal 1. There's my restriction. Okay, so here we would normally say that this is square root, so it's not 1-to-1. But here's our restriction, and since it has the restriction, it's probably talking about only the positive square root here, the principled root. So let's go ahead and do that. Switch our y for f of x. We can go ahead and exchange x and y. Then we can go ahead and solve for y, and because this has a restriction, that means our inverse function should have a restriction as well on the domain. And we go ahead and solve for y. Get rid of square root by squaring both sides. Subtract 6. Now we can switch f inverse of x. Okay, now we just want to say our domain, right? That is going to be the domain of the inverse is our range, because our x's are our domain and our y's are the range. But when we do inverses, we switch our x's and y's. So that means my range of my regular function is actually the domain of my inverse function, and my domain is actually going to be my range because the x's and y's are basically switching. Okay, so that means we need to find the range of the original one. So as I plug in numbers that are greater than -6, so that would be -6, so -6 I would get 0, right? So at -6 I would get 0, and where's it going to go from there? 0, square root of 1, square root of 2, it's all going to go up from there, right? So that's from 0 to positive infinity is my range of my original, so that means my domain is going to be from 0 to positive infinity, or I can write it as an interval, or inequality, not an interval. You can write it as an interval to 0 to positive infinity. Okay, so here's 77. They give you a graph, something like this, and they say it looks like this. It starts at 0, 0, and it goes like this. And then they give you that line. They give you that line of y equals x that flips that. So basically, if you had paper, you could fold that in half, and then you can maybe trace it, right? So you can do your best at this. But if I have an x value, it's y, it's 0, 0, right? So that's going to switch to 0, 0, so that really kind of doesn't help you out there. But it kind of gives you a graph paper, so you can kind of look and see, is there any point that I can find? And one point is 2, 2. One point is 2, 2. So that means it's going to switch to 2, 2. So that means it's going to look like a quadratic, but it's gonna flip, right? So it's actually going to be like that. And so if you had paper, you could better see that, how it folds along that line. And you might be able to look for maybe closer points that can help you flip those. These two were exactly the same, so it's kind of hard. but you flip it over that line, you fold it about that line, and you can see this is half of a quadratic, so that means it's 1 to 1 because it's only 1/2. That means the inverse would be the principal square root, and that is also going to be 1 to 1. Okay, so here's 81. They give you this line, and then they give you the line of y equals x, and they say, okay, draw the inverse. So this one's a little better in 77 because you actually are given some points that you can find 1, 3. So you have a point 1, comma 3 of the original, and you have point -1, comma -3. So now you can actually literally switch the x's and y's for your inverse function. So 3, 1, and -3, -1. And now I can actually go ahead and graph those on a point, right? So 3, 1, -3, -1. And now I can go ahead and draw my line right through there. So there's the inverse function. Alright, so those are all the problems. Hope you enjoyed.